have to
Okay,
stop sharing.
yeah. The
Okay.
slide is clear. Okay.
Mhm.
Yeah, before you deliver your materials, we will have opening speech by our dean. But in this occasion, our head of department will deliver the speech.
Okay.
Yeah.
Sure.
Okay. How about the Malaysia weather right now, Selangor?
Yeah. Currently it is. I think it's really I think it's raining, but not really heavy. Okay, just mendung, cuaca mendung. How to say? You know, mendung? It's cloudy, but it's not really heavily raining. Okay. But it's quite chill, a little bit cold right now. How in Indonesia? Rashida, are you hearing me?
Okay, I'm asking you, but suddenly my Zoom bit error.
Okay. I'm sorry.
Yeah.
I also afraid if if my line is also not good. Hopefully it's smooth, inshallah. Hopefully.
Okay. Yeah,
Okay.
so far your connection is good.
Good. Okay.
Sometimes
Alhamdulillah.
my connection is not really well here,
Okay.
but I
All
have
right.
to fix it.
Okay.
Okay. Okay, Dr. Norasma, we will start the program. And for the first, we have Master of Ceremony to start this meeting. Please,
Okay.
the MC.
Okay. Ladies and gentlemen, attention please. Our opening ceremony is about to begin. Good morning, ladies and gentlemen. Welcome to Invited Lecture Series, Smart Farming using Precision Agriculture, Crop and Weed Management using Remote Sensing, organized by Agri-Technology Study Program, Faculty of Animal and Agricultural Sciences, Universitas Diponegoro, Semarang. Ladies and gentlemen, it is a great honor for me, Irfan Yusuf, as Master of Ceremony, to be here and welcome every one of you in. Ladies and gentlemen, over the next few hours, this meeting will provide you plenty of opportunities to discuss, share knowledge, and insight. Ladies and gentlemen, before we proceed to the program today, we would like to express a sincere gratitude to Honorable Rector of Universitas Diponegoro, Professor Dr. Yos Johan Utama SHM, Honorable Dean Faculty of Animal and Agricultural Sciences, Universitas Diponegoro, Profesor Dr. Insinyur Bambang Walio Hadi Eko Prasetyono MSM Ager IPU, Honorable Head of Agricultural Department, Dr. Henny Rizkyati SPT MSc, Honorable invited speakers, students, and participants. Ladies and gentlemen, before we proceed to the main agenda, we are now going to listen and listening to our national anthem, Indonesia Raya. Ladies and gentlemen, please stand up. Ladies and gentlemen, please sit down. Ladies and gentlemen, we are now going to listen to the opening speech delivered by the Dean Faculty of Animal and Agricultural Sciences. In this occasion, Dr. Henny Rizkyati SPT MSc, as the head of Agriculture Department, will deliver his speech.
Okay, thank you MC Mas Irfan. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, student and all participants joining us online. We are welcome you to the Invite Lecture Series organized by Agroecotechnology Study Program, Faculty of Animal and Agricultural Sciences, Universitas Diponegoro, and thank you very much for your participation in this event. First, may I thank the speaker or the invited lecturer, Dr. Cik Norasma, a senior lecturer from University of Putra, Malaysia, for taking part in Invite lecture series number 1. It is my great pleasure to welcome you to the Universitas Diponegoro, Faculty of Animal and Agricultural Sciences. Universitas Diponegoro is the reputable faculty in Indonesia and in the world. Faculty of Animal and Agricultural Sciences has 7 study programs, starting from Bachelor of Animal Science, Bachelor of Agroecotechnology, Bachelor of Food Technology, Bachelor of Agribusiness, Master of Agribusiness, Master of Animal Science, and Doctor of Animal Science. The 3 study program at Faculty of Animal and Agricultural Science have also received international accreditation. Based on the US World University ranking, our faculty managed to rank 400 plus in the world in the field of agriculture. Even the QS graduate employability ranking put Universitas Diponegoro is first place. Every year, we are holding our annual event, which is an invited or visiting lecture. As we come together today with the topic of smart farming and precision agriculture, crop and weed management using remote sensing. Through this invite lecture program, we hope students may enlarge their knowledge of modern, smart, and precision agriculture practice. We are truly grateful for this. So by coming here, you are helping us to build and develop the knowledge that is related to the smart, precision, and even future farming that will be faced by our students. Last but not least, my deep gratitude goes to all committees who have directly and indirectly support the success of this invite lecture program. Although we try our finds to be professional on behalf of Universitas Diponegoro, please accept our sincere apologies so there be inconvenience that occur before, during, or after event. With this word, I declare the invited lecture series open. May God bless us all with good health to make this event a successful and enjoyable one. Thank you. Terima kasih, Mas MC.
Sama-sama, Ibu. Thank you to Dr. Henny Rizkyati, SPT MSc, for the delivered speech. Ladies and gentlemen, before we move on to the main agenda, let us take some pictures to immortalize this very moment. For all participants and speakers, please turn on your camera.
Okay, maybe I will here in 3 count. Yes, 1, 2, and 3. Cheese. The next 1 and 2 and 3. Cheese. Okay.
Thank you, everyone, for your sincerity. Ladies and gentlemen, now we come to the main program, who will be directed our moderator, Sepril Arafat, SP, MP. First of all, allow me to introduce our moderator, Sepril Arafat, SP, MP. He is currently the lecturer of Agroecotechnology Study Program, Department of Agriculture, of Animal and Agricultural Sciences, Universitas Diponegoro, and his expertise is on soil sciences, particularly land survey and management. To Central Arafat, SP, MP, the time is yours.
Okay, thanks for the time. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I hope all of us are in good condition today. Ndvi's agriculture provide humanity with food, fiber, fuel, and raw material that are essential for human. Today, this rule must be satisfied within a context of environmental sustainability and climate change. Remote sensing has the capacity to assist the adaptive evolution of agriculture practice in order to face this major challenge. Okay, in this morning, I'm very pleased to welcome you to our invited lecture series. And today, 10 October, is the first series of invited lecture program. First, let me introduce myself. My name is Septrial Arafat, but I think it's easier to call me Arafat. I'm from Agricultural Technology program. Today, I will accompany our honorable speaker to lead the discussion. And now, we all already have Dr. Nurasma Cekya with us. Assalamualaikum, Dr. Nurasma.
Waalaikumsalam. How are you,
Yes.
Arafat?
Yes, I'm fine. Okay, everyone. Before we move to the main session, let me give a brief introduction about our speaker. Okay. Miss Dr. Nurasma Cekya is a lecturer in Department of Agriculture Technology, University Putra Malaysia. This is one of the best campus in Malaysia, I think. And the education, Miss Dr. Nurasma start from University Technology Malaysia for PSG, MSc in University Putra Malaysia, and obtained PhD in University of Queensland. Mrs. Dr. Nurasma research interest in geographic information system and WebGIS or drone precision agriculture in rice production in Malaysia. And second interest from Miss Dr. Nurasma is about site specific with management using remote sensing. This interest I think linear with Dr. Nurasma professional bodies, yakni Institution of Geospatial and Remote Sensing Malaysia and International Society for Southern Asia Agriculture Science. And this mean that Miss Dr. Nurasma is a great lecturer to speak about GIS for crop and wheat management. Okay, before the entering to Dr. Nurasma session, I hope the student here or all the participant will enjoy like you study in the class. Just listen carefully and enjoying in the session. I think understanding about remote sensing is more important than bahasa. Okay, no. Allow me to welcome our speaker to deliver his presentation. Dr. Nurasma, are you ready?
Yes, Arafat.
Okay, yeah, the time is yours.
All right. Thank you so much, Arafat, for the introductions. Okay.
Okay.
So I try to share my screen. Can you see my screen now? Okay.
Yes.
All right. Okay. So Bismillahirrahmanirrahim. Allahumma salli ala Sayyidina Muhammad wa ala alihi wa sahbihi wasallam. So, Assalamualaikum warahmatullahi wabarakatuh and very good morning to everyone. So, today I really honored to be here and thank you to the organizer from Agro-Technology Study Program, Faculty of Animal and Agriculture Science, Diponegoro University, Indonesia, for inviting me, especially to Roshida, who actually contact me. Okay, after so long we didn't meet. Okay, I think last for several years, right? We can see.
Yeah.
Okay. Yes. And then thank you so much because we still keep in touch. So hopefully today I will share some of my experience and my work that I have been done during my PhD, and also during I continue in UPM. Okay. So the title for my presentation today is Smart Farming and Precision Agriculture, and we are focusing on crop and weed management using remote sensing. But I also try to give you several applications that have been used in different applications. For example, in IoT, in tomato cherry, and also others application in remote sensing. Okay. So before we start, okay, this is the outline for my presentation. I will give you a brief about the UPM. Maybe some of you not really familiar. Where is UPM? And introduction about the smart farming and precision agriculture, and also the weed detection using remote sensing. And then I will give you a more some application that I have been done, okay, especially in smart farming and precision agriculture. So before we start, I would like to introduce my university. Is University Putra Malaysia, UPM. So we call UPM because previously it's actually University Pertanian Malaysia, but then it's changed the name to Putra Malaysia. And UPM is actually one of the research university in Malaysia. It's public university, and we have about 15 faculties in UPM, and one of the faculty is Faculty of Agriculture. Okay, and also we have 11 institutes, and we work closely with the Institute of Tropical Agriculture and Food Security, ITAFOS, because the institute is really related to our faculty, which is in crop and animal. Okay. And also we have the mobility program. So if you want to come to UPM, you can do the mobility or exchange student. Okay. So if you want to study something new, okay, explore in Malaysia, please welcome. Okay, we have a mobility program for the undergraduate and for the postgraduate student as well. Okay, please come to UPM. So this is my faculty, Faculty of Agriculture. Okay. And in my faculty, we have 7 departments. I think it's quite related or quite similar with your faculty. Okay, we have Department of Crop Science, Department of Plant Protections, Land Management, Animal Science, Agriculture Technology, which is my department. I am from Department of Agriculture Technology, Agribusiness and Aquaculture. Okay, so I think it's quite similar with Ibu Heni Rizkiati just mentioned just now. And we also have 7 undergraduate program, which is Bachelor of Agriculture Science, Horticulture, Aquaculture, Animal Science, Agribusiness, and also Plant Protection, Plant Management. But started for this year, we actually have a new program known as Bachelor of Technology in Smart Farming. Okay, for this program is actually focusing on technology, okay, especially smart farming technology in agriculture, and we just offer this semester. Okay, so we have new students in this month, which is the first semesters. And if you want to continue or have want to further study, we also have a postgraduate program for the PhD and masters by research, and also master by coursework. Okay, so please come to UPM. Okay, maybe we can learn each other and exchange our knowledge. Okay, and hopefully you can explore Malaysia. Okay. And this is some facilities in UPM. We have a glass house. Of course, we are under Faculty of Agriculture. We have our own farm, aquaculture area for the animals, and also exchange student. We always accept all the international students to come to Malaysia or to come to UPM to do their summer camp and so on. Okay, so please come to UPM. So that's a brief, okay, about the UPM, University Putra Malaysia. So if you want to come, you can contact me anytime. I will liaise you to the admin in our faculty. Okay, so back to our business. Okay, we want to talk about precision farming or smart farming. All right, so smart farming. Okay, I think some of you already familiar with the smart farming terms. Okay, and as you know, the concept of the smart farming is actually related to many technologies. Okay, such as the IoT, of course, the robotics, drones. Okay, artificial intelligence. Okay, just to increase the quality and productivity, okay, of the yield, especially for the yield. We talk about agriculture perspective, and also is actually filling the gap, okay, between the sensors and the machine, okay, so that we can manage the farm effectively, okay, where we actually can monitor the farm by using the smartphone, for example. Okay, we can monitor our irrigation system by using our smartphone, okay, for example. And all the data we actually can gather in one database we call as like big data, that we can do the analysis later on, or we can do the prediction. Okay, and this also include the UAV, or we call as drone. Okay, UAV is actually the term of unmanned aerial vehicles, but also known as drone. I think most of people like to use drone. Okay, it's easy to pronounce and understand. So the precision agriculture is actually also known as the site-specific crop management, where they actually based on the observation, measuring and responding to the area. For example, okay, if you see the tractor here, okay, they actually connected, okay, connected with the satellite that can give you the higher accuracy of the position system. Okay, so that you can actually know where is your location, where you harvest or where you plant your seeds. At the same time, okay, at the tractor maybe have a sensor that can scan, okay, they scan the area so that you know the condition of the soil, okay, at particular area. So that the precision agriculture is actually focusing on uh, the existing condition or existing nutrient in the area. Okay, and then when we know the existing condition or nutrient in the soil or at the leaf of the plants, we can calculate how much we can put the input. So that's why we call precision, because we need to calculate the precise amount of the input, so that when we apply the input, for example fertilizer, we apply with very accurate amount. Okay, this also known as 3R: right location, right place, and right time. Okay, so this is also integrated between the satellite imagery, drone, okay, to do a mapping, okay, and to create the variable rate applications. Okay, so in precision agriculture is actually related integrated with many technologies. Of course, it started with the GPS because we want to know the location, okay, and then the UAV is for the data collections, okay, for mapping, and smartphone. Okay, because normally we use a smartphone, and I think even farmers nowadays, they have their own smartphone. They do a lot of work, okay, or they find the information using the smartphone. And then for image processing, we can use the GIS, or we can use the remote sensing software to do the analysis. And finally, we get the final result, or we can do some interpretation or recommendation to the farmers. Okay, that's how the holistic concept of precision agriculture. And now we already use the IoT, okay, IoT system that called as smart farming, where we actually integrate as well with the IoT. If you remember my first slide, I said that smart farming is actually a gap, filling the gap between the IoT and the UAV, okay, or drone, okay. So this is actually integrated each other, and we need this kind of technology to implement precision agriculture method. So I will go one by one after this, so that you will get more familiar about this technology. Okay, so in Malaysia, to do the UAV or drone application, we need to apply a permit. I'm not sure in Indonesia, but in Malaysia, even though we want to do the agriculture purpose, we still need to apply the permit. This is very important because is will control and also can for the safety reason, okay, especially for the public people, and as well to the pilot, okay, for the pilot drone, because a drone is actually is really dangerous if you didn't control properly, okay. It's just a tool. Okay, so for the safety guidelines, you need to not allowed to fly near to the airport, okay, and you need to make sure you can see the drone when you fly, and you need to make sure it's not hazard to another aircraft. So that's the general information about the drone. Because my research is more on GIS and drone, so I will give you more research what I have been done in using drone technology. Okay, so based on the literature, you can see a lot of information, okay, that use drone in agriculture, okay, and even in Malaysia we use this kind of technology in paddy field, oil palm, in rubber, okay. So actually you can explore. I think Indonesia is more advanced, and I think you actually more explore this kind of technology, okay. And now in this webinar, we actually focus on weed mapping, right? Weed management. So how we want to detect weed, okay, in the crop. So we need to make sure what kind of sensor is suitable to detect the weed. Okay, so even though you use drone, you use the UAV, there is a lot of camera or payload that available, and which sensor is suitable to detect the weed, for example. So you need to know your purpose, what you want to do, what is your objective, and then you can study what kind of sensor is suitable for your drone data. Okay, because each sensor will give you a different data set. Okay, so this is really important. Sometimes they only have RGB sensor or RGB camera, but they want to do a very advanced analysis. So you need to know the limitation. Okay, we cannot scan everything. We need to make sure we have a suitable camera or sensors. Okay. So I just give you a brief about type of drones. Okay, since I work a lot with this kind of drones. Okay, so basically we have multi-rotor, fixed wing, single rotors. So this is the multi-rotor drones. Okay, why they call multi-rotors? Because they have 4 propellers and above, and multiple. That's why we call it as multi-rotor. So this is the Inspire DJI. Okay, so we use Inspire DJI to carry the multispectral sensor. Okay, so if you buy from the DJI company, Inspire is actually carry the original sensor known as GoPro. Okay, this is the GoPro camera. The UAV, the drone here is only carry the RGB camera. So we change the GoPro to the multispectral. Okay, so that this drone can carry the multispectral and get the multispectral imagery. Okay, so I will show you after this the video how we change the sensors, And of course, we have the RGB camera. This is, I think, really common, and I think most of you already know how to fly this. Straightforward, very easy. And now, I think DJI also produced a new multispectral for Phantom. So you can also easily fly the multispectral using the Phantom. And this is a thermal drone, okay, that actually measure the temperature of the crop. Okay, so this is a thermal drone. The drone is actually come from China, known as Unix drone. Okay, and this is our new drone. Okay, just arrived about this year. This drone, sorry, this drone is actually carry the hyperspectral sensor, okay, known as PKL. So now you can see, and you can, if you are focused, you can see there is a different sensor for the drone. Okay, RGB, multispectral, thermal, and hyperspectral, right? So you need to know, okay, which sensor is suitable for your project. Okay. And this is the single rotor, where it's actually, it looks like a helicopter but a small scale or small size. And normally this one is for spraying, okay, for herbicide application or pesticide applications. Okay, for example, like Yamaha, Armax, and that's why we call as multi-rotor, because they only have one propeller. And fixed wings is actually it looks like a real aircraft but a small size. Okay, but for the fixed wing, it can fly higher compared to the multispectral, and it can cover more area compared to the multispectral. So if you need to know how big your area, okay, and then what is the altitude you want to fly, what is the resolution for your image. Okay, if you want a higher elevation, or you want to fly more than 100 meter, the fixed wing is suitable for your data set. So you need to know what is the spatial resolution that you need for your project. And this fixed wing also can carry the RGB and multispectral sensor, and we have here this is the fixed wing that also carry the multispectral Picasen parrot sequoia. Okay, so this is just the preparation before we fly. We need to make sure it's sunny and not rainy, because what we capture is actually the light, the reflectance of light. We need sunlight. Okay, and you need to make sure you have bring extra battery. Okay, because as I mentioned, UAV or drone is just a tool. It's just a tool, and you need to check, because they really depend on the batteries. Okay, so normally if I go to the site, I will bring extra battery so that we can easily change, okay, rather than we charge. Okay, and we need to check the waypoint, okay, for the areas, and this is the overlap that recommended by the drone deployed. Okay, so normally for multispectral and RGB, we recommend to you have more than 20% and 70% overlap. Okay, I think you need to have more than 70% overlap so that you can get a good data set. Okay, a good, high accuracy image, because this image, for example, one image here is actually snapped by the drone. So the drone will capture every second. Okay, so when you set the overlap, if you set 20%, they just only overlap 20%. And sometimes when the drone fly, sometimes there has many factors like wind. Okay, so it will affect your resolution or quality of image. So if you have 70% overlap, it will give you higher accuracy and quality of your data set, because after that we will mosaic your image. Okay, to get a whole map. Okay, so this is the recommendation. Okay, if you want to do the what the purpose of your study, if you want to do the crop monitoring, okay, is really recommend to fly below than 100 meter. Okay, so it depends. Okay, so how to know this kind of specification? You need to study from the literature review, or you also can test. Okay, maybe you can fly at different height, and then you can check which height will give you a higher accuracy or better classification for your objective. Okay, so I will share with you several data that have a different altitude or different spatial resolution. Okay, this is the paddy field. Okay, sawah padi in Malaysia, and we want to detect weed. Okay, and we fly at this is about a day after sowing 7 days. Okay, and we fly at, I think this is at 10 meters. Okay, wait a second, I cannot see. Okay, this is for the 10 meters, and then you can see the shape of the leaf, right? Very accurate. Even you can see the flower of the weed. Okay, it's really sharp, really high accuracy. Okay, and then if you fly at 20 meters, you can see the difference already. Okay, at this 20 meter, you cannot see the color of flowers. Okay, but you still can see the shape of the different leaves. Okay, the broad leaf, leafy leaves, right? And at 40 meters, okay, you can see the image is already blurred. Okay, the pixel is already bigger, and it is not really sharp like the previous 20 meters. Okay, and then when you fly at 60 meters, okay, the pixel is more blur, and you can see the different color of the pixel. Even though it's 60 meters, you still can do the analysis. Okay, because if you see properly, the color of the pixel is different. There is a variation of the color of the green. This is only RGB image. Okay, this is only RGB image, and you can see there is a dark green, there is light green. So this is actually classify something in this plot. Of course, in this plot is actually for rice, okay, paddy field and the weeds. So what we want to do is we want to detect the weeds. All right. Okay, now as I mentioned, the precision agriculture just now, okay, is related to the UAV, which is the drone, okay, and also is related to the remote sensing. Okay, so as you know, remote sensing can do a lot of application in agriculture. For example, the crop growth status, okay, crop stress, information, nutrient insufficiency, monitoring, and so on. So we can do a lot, but which sensor, which data set that can do this kind of analysis? So you need to know. So we also use the hyperspectral data, okay, because as you know, the weed in the, especially in rice field, because I work a lot in rice farming, but I'm not the expert in rice. So I just use the technology to do the analysis. Okay, when we check the image in the map, the wheat and the rice is really similar, quite similar. The shape, the color, you know, and especially rice, because rice is leafy leaves. Okay, so it's really hard to differentiate. Okay, so what we want to do, we try to use the hyperspectral. Okay, because the hyperspectral have a narrow band, and it can use to identify or discriminate the species in the crop. Okay, so I will share with you some of the preliminary research that we just started by this year. Okay, this is another project by my student, a PhD student, that actually implement the machine learning in hyperspectral, okay, in broadleaf, in rice. Okay, so I give you just it just started, and we didn't get findings yet, but I can share with you the progress. Okay, the progress what we done. Okay, as you know, weed is really a problem, of course, in rice field. because it can decrease the yield by 45%. Okay. And of course, it have a competitor, okay, and it can block the drainage, and finally, it can have a high resistance, okay, towards the weed herbicide. So, by using the hyperspectral, okay, we can actually extract the information. So, I already mentioned about the sensor before this, RGB, multispectral, and hyperspectral. So, what is the difference? I will show you after this, okay, the difference between the three sensors so that you can see the difference, okay. And hyperspectral is actually can give you more information because it can be in 3D system and you can run using the machine learning, okay. With the machine learning algorithm, we can actually calculate the statistical analysis and classify the wheat and the crop, okay. Because as I mentioned, wheat and crop, especially in rice, is quite similar, really hard to differentiate. If you see by your own eyes, you can see it's quite similar. You cannot differentiate, okay. So recently we published some papers, okay. So it's proof, okay, by using the hyperspectral, we can actually discriminate or classify the wheat species, okay. And by using the hyperspectral, you can see when hyperspectral have a narrow band, okay, and it shows in one cube like this, meaning that each pixel have thousand nanometers that we can actually do the analysis, okay, for the classification between weeds and paddy field, okay. So this is the comparison, okay, for the sensors, okay. RGB, if you see the your handphone, okay, your handphone is actually have RGB. Even your eyes, what we can see with our eyes is only visible band RGB. But for the multispectral, is normally can have 4 bands and above, maybe 4 band to 12 bands, okay. And some of the bands we cannot see, especially for the infrared and above, all right. But for the hyperspectral, you can see there is more narrow band, okay, and it's really huge, okay. That's why we call as hyper, because it's really huge band, and compared to the multispectral that we still can count, and RGB only 3 is fixed 3, okay. But multispectral can be 4, 5, can be 6, and can be up to 12, all right. So hopefully you can see the difference, okay, between the RGB and multispectral and hyperspectral, okay. So the RGB, you can see the 3 band here. Multispectral, there is several bands. It depends on your sensor. Some sensor have 4 bands, some sensor have 5, 6, and up to 12. And also you can see the difference with the hyperspectral here, okay. It's very narrow down band and didn't have any missing data. If you see the multispectral, there is some gaps, okay. Gaps meaning that didn't have any data between that band, between that band. But here didn't have any gap because each band interval is about 1 nanometer or 10 nanometer interval, is very narrow, okay. So that's the reason why we can get a very high accuracy for the classification or detection. Okay, now if you see this is the spectral signature, okay, for the hyperspectral data, okay. So in plant, okay, they do the photosynthesis, they use the blue and red, okay. They observe the color, observe the green, the blue and the red color to do the photosynthesis. Chlorophyll will observe that light, okay. But they reflect the green color, okay. Here this is the green. That's the reason why you can see plant is green color, because what we see here is all the reflection, okay. Anything we see is actually reflection, that's we can see the color, okay. But for the near infrared, in plant, they actually reflect more, okay, because of the spongy effect, and by the limitation of our eyes, we cannot see the near infrared, okay. That's our limitation of our eyes. That's the reason why we use the hyperspectral tool or hyperspectral sensor to measure how much the reflectance of the plants using the spectrograph here. Okay, so our eyes only can see invisible here, RGB, and then up to near infrared, we cannot see, even though the plant is reflect so much, a lot, up to more than up to 50%. But because of our limitation, we cannot see, so we use the sensor to measure the reading. Okay, and if it goes down back because of the water absorptions, okay, and it goes a little bit and then go down again. So from this graph, okay, you can check the condition of the crop, whether the crop is healthy or unhealthy or stress and so on. Okay, so this is the example of the normal spectral signature. Okay, and if we compare between the healthy and unhealthy leaf, okay, you can see the difference. Okay, so the unhealthy leaf will reflect higher at the visible band, okay, but lowers at the near infrared band. Okay, but for the healthy, it reflects is lowers than the stress leaf, but higher at the near infrared. So normally for the healthy plants, it will reflect more than 50%. Okay, so normally if more than 50% reflection is considered as healthy plants. Okay, but below than that, we can consider have stress or have any problem, pest and disease and so on. So you need to know first how the healthy leaf looks like. Then you can compare with your data set later on. Okay, so this is we call as spectral signature from the hyperspectral data, hyperspectral sensor. Okay, and from the literature review, you can see a lot of method, okay, or analysis that use in machine learning to run the weak classifications, okay, using the hyperspectral, for example, like discriminant analysis, ANN, okay, support vector machine and so on. Okay, and you can see which one is give the higher accuracies. Okay, and this is the difference of the band that's significant to classify the weeds. Okay, which band have a higher accuracy to classify the weed and the crop. Okay, so if you see here, it looks like is most of the wavelength is actually started at near infrared and above. So that's the advantage if we have the hyperspectral or multispectral, because they have the near infrared band that actually can use as an indicator to differentiate the species, okay, or classify the crop, whether the crop is healthy or unhealthy or different species. Okay, so this is my student objective, okay, to identify the characteristic of broadleaf weeds, discriminate the spectral signature, and then finally to produce the weed mapping. Okay, so we did in Velcra Seberang Perak. Okay, this is a paddy field with the rice plant variety MR297 and MR315. Okay, and but in this research, we only focus on broadleaf. Okay, some other research, another my students focus on leafy grass. Okay, so we for today, I just show you for the broadleaf species only, and we use the hyperspectral resonant PKL with the multispectral drone, multi-rotor drone M600. Okay, and this is the area in Velcra. Okay, we do two experiments, one experiment in the field, one experiment in the glass house. And then for the glass house, we capture for the pure spectral signature, and then we compare with the field experiment. Okay, so this is the experiment under the glass house. We also capture the spectral signature. We plant the rice in the pot, and then we use the PKL resonance. Okay, this is the hyperspectral range up to 1000 nanometers, and we use drone to carry the sensor and capture the image. Okay, this is the drone that capture the carry the payload of hyperspectral. So the drone is just a tool that we can actually change what payload we want to put. But this drone is specifically for the hyperspectral sensors. Okay, and of course we have the RGB drone. This is really quite common. I think all of you already used this before. And this is the type of rice, two different types of rice and three different type of wheat. Okay, broadleaf wheats. Okay, so this is the method. Okay, how we collect the hyperspectral at the ground and do the processing, and then also we run the machine learning algorithm to do classification. Okay, so you can see here, there's a subplot here because we do some RCBD, and also we do some experiment and treatment, different treatment. Okay, so we still in ongoing research. We didn't get the result in hyperspectral yet, but we have the RGB map. Okay, so this is the length preparation before we start the experiment. Okay, and we also collect the spec data and grain seeker. Okay, so this is as our ground truth. Okay, ground truth for the cross check the imagery. Okay, sorry for that. And then we digitize the vector data so that we have the plot area boundary, and we link the ground data to this spatial information. Okay, so this is more on GIS software that I think maybe some of you already familiar with GIS. So this is how we mapping the wheat. Okay, so we can see the distribution of wheat in the crop. But this result is actually not hyperspectral yet, but because we didn't have that result yet, but this is just only from the RGB drone. Okay, and then I will share with you my PhD research during my studies in University of Queensland with the title of Site-Specific Weed Management using remote sensing. Okay, so I didn't share all of the research. I just picked some of the important points that related to today's lecture. All right. So I think I already mentioned about site-specific weed management is based on the weed patches. Okay, it's really important. And of course, weed application costs a lot of money. Okay, it's really expensive. Okay, input is really expensive. So we want to minimize. How we want to minimize? We need to do the spot spraying. That's what we call as site-specific weed management. Instead of we just apply the blanket application, because not all your field or not all your plot need that herbicide, right? Maybe some of the area have a lot of weed need that herbicide. So why we want to waste the input? Because the input is really expensive, right? So we want to control the input and save some money, and at the same time we want to control the chemical effect for the environment. Okay, and again in this research we actually use the hyperspectral sensor. Okay, but in my research here we didn't use the drone hyperspectral, but we use the portable hyperspectral. Okay, but in the hyperspectral here, just we managed to get the spectral signature only, not the image. Okay, and then for the objective of my study to discriminate between wheat and sorghum. In this case, we plant sorghum, identify the multispectral image, evaluate the image processing, and also to produce the wheat map. Okay, so this is the methodology. So far is the concept is same. Okay, it's a standard procedure, but what is the difference is the method, the analysis here. Okay, the image processing, what the method that you choose. Okay, during this study, I used the object-based image analysis because the object-based image analysis that time is still new. Okay, it's quite new. Everybody want to try, you know, and I also try use this method, and I get the I think quite good results. Okay, so this is my study area in University of Queensland in Gatton campus. So in Queensland, it's actually have several campus. Okay, the main campus is actually in Brisbane, in city of Brisbane. But my campus in Gatton here is actually focused on agriculture and veterinary. Okay, so in this campus is quite small but have a very big farm. Okay, so this is focused only on agriculture and veterinary. There's a lot of cows, horses, sheep. Okay, so we are located. It is quite far from the city. I think if you drive from the Brisbane, it is maybe take 1 hour to reach our campus. Okay. And we use the tractor case 95 with the GPS. And this tractor, I still remember, I use the automatic steering wheel so that they follow all the crop row precisely. Okay. And then we collect the wheat information for the ground data for 2012 for 3 years and up to 2014. And then this is the area we compare for the pre-emergence and non-pre-emergence and how it looks like when we do the using the hyperspectral and drone. So the data collection is actually involved with hyperspectral portable. This hyperspectral is different with the hyperspectral that I mentioned before because this is the portable device, not the drone sensors. Okay. And I also collect the moisture content, the multispectral UAV, and also RGB. So this is the hyperspectral device, okay, called as AST handheld spectroradiometer. During I do the data collection for sorghum, this is the crop of sorghum, and you can see this is the fiber optic. When we want to take the data, we need to make sure the fiber optic is about 5 centimeter to the object. Okay, so that you will get accurate data. Okay, so it's too far, maybe it will affected by the surrounded area, or too near, maybe you didn't get the actual object. Okay, so you need to make sure it's about 5 centimeters, and you need to check from the literature how they do. Okay. And then the step also, some step you have to follow to get the spectral signature. Okay. And then I use the R software to do the structure of the data set, and then to do the pre-processing for bin and smoothing the area, the spectral signature, and the first derivative. Okay, so that we when we run the first derivative analysis, we can see more clearly where is the difference of the spectral signature. Okay, and then we also run the statistical analysis. Okay, for the statistical analysis, we use the linear discriminant analysis so that you can know which band is significant to classify the wheat species. Okay, so I will show you based on this result, we use the significant band to buy our multispectral sensor filters, so that when we fly the multispectral sensor, that filters or the band is actually really significant to discriminate the wheats. Okay, I will show you later on. And also we compare with the static image where this sensor here, a multispectral sensor, is only about 1.6 meters, and we managed to get very high accuracy just to compare with the drone data later on. Okay, so we use the microcopter with the MCA6 sensor. So this is a multispectral. Okay, if you see here, there is a 6-band. Okay, 1, 2, 3, 4, 5, 6. So this 6-band have a different wavelength. Okay, so each band I identify, I request or I bought from the factory based on my analysis previously from the hyperspectral data. Okay, remember this analysis come up with the significant band. Okay, 6 significant band. So I put this 6 significant band to the multispectral here, because these filters we can request to the manufacturer which band you want. For example, 720 nanometer or 450 nanometer. So you can request, and then they will fix to the sensor and you can fly the drone. So we need to do a normal procedure. You need to do the waypoint at the ground stations, and then set the GPS and so on. And we see the result. Of course, this is from the hyperspectral signature. You can see the different curve. The spectral signature also, if you hard to understand, okay, if you are first time heard this, it's like our signature. Okay, you, for example, Irfan have his own signature, Arafat have his own signature, right? Signature. So it's same like plants. That's why we call spectral signature. So each plant have their own spectral signature, very unique. So we, from that unique spectral signature, we can use to identify the species. Instead of we use from our eyes, we can differentiate because we see it looks more similar, same species. But when we use the hyperspectral, we can see the difference. Okay, and we also run the linear discriminant analysis. Okay, for each width and crop, and finally we can get the highest significant bands. Okay, from the result we got 8 bands. Okay, but since in red H have 4 bands available, so we just choose 420 and 720 and 710 to be fixed in our multispectral. So this is the result we got from the hyperspectral statistical analysis, and we put the 6 band here: 850, 720, 710, 680, 560, and 440 to our multispectral sensor. This is the 6 band significant band we put here. Okay, we put one by one here, so that our multispectral is actually focus and have an advantage to discriminate the species. Okay, because our hyperspectral before is just the portable at the ground, but now we want to use the same band in the drone. Okay, so this is the step for the pre-processing up to mosaic. I think it's quite straightforward, but MCA that I use this sensor, okay, MCA6, it's really hard to mosaic. It's not like Phantom, it's not like normal drone, because the image is not stacking automatically. Remember, we have 6 band, 1, 2, 3, 4, 5, 6, right? So we have to do manually to stitch, to stick together, and then to mosaic. So it's quite tedious works, and I also feel so hard to do this. But now it's okay. You can use multispectral. Phantom is really easy to use. It's straightforward. Mosaic to use. You just use the Agisoft, right? But now here we cannot use the Agisoft. You need to use the specific software for this sensor. Okay, and what the difference with others, we use the object-based image analysis and vegetation index to come up with the weed classification. So this is the object-based image analysis. We use the e-connections. If you are familiar with the e-code software, um, so what this software do is actually classify the object itself. Okay, so you need to do the segmentation and then classify between the soil and vegetation. And in the vegetation, you need to classify, reclassify to the wheat and to the sorghum. Sorghum is our crop, okay? And then in the wheat, you need to classify to different species, okay? So you can see how the hierarchy from the original scene and then is narrowed down to the species plants, okay? And then this is the classification method, and you need to try and error. You need to run based on the literature and try and error which classification is suitable until you get the higher accuracy of your image, okay? But when you get this entire tree, you can actually modify to be an automatic classification. For example, just you do a programming using this method or you do using this parameter. By using one click, you can classify straight away the weed, which is during my PhD, I didn't have time to do that. I'm not expert in programming. I'm not programming background. So I just do semi-manually, okay? So finally, you can see this is how it's classified, the segmentation based on the object, okay? And then from the vegetation here, the green, we want to classify to the wheat. So finally, we do the classification and you can see the wheat become green and the crop become yellow. But some of the area, maybe there is some misclassification. That's why we still have the area assessment to validate this method, okay? And also we run the same method for the area imagery at 10 meter altitude, which is very high resolution. So you can see it can detect some of the areas. So this is how where we can actually apply the herbicide. We no need to apply for the whole area for the blanket application. We just apply the herbicide or the input to the spot area that have a bigger patches, bigger wheat patches, right? So that's how we can actually save the input and also our environment, okay? And this is the accuracy when we actually also check at different altitude. Okay, so that's why when you want to use the drone technology, I really encourage you to fly at different altitude, different elevation, so that you can get a different resolutions. And based on that resolution, you can identify which one is the optimal resolution you can fly. You can do some recommendation, okay? Of course, the higher accuracy, the higher spatial resolution, we get you a higher accuracy. Okay, so this is the of course it have a significant, okay, in when we use the hyperspectral, okay, and maybe in future study we can do the linear area index analysis to build the spectral signature, because I think in Malaysia we didn't have spectral signature yet, but I don't know in Indonesia. But in Australia, they have the spectral signature library. Okay, so that's one project from my PhD. After I finish my PhD, I continue the same research in UPM. Okay, I try to brought all this kind of my knowledge and my skill in UPM. Okay, and I think they also quite new right now, where we use the UAV or drone, especially in precision agriculture. So this one is actually together with the Institute of Tropical and Security Makanan, ITAFOS, in UPM. So I will share you a video how we actually set up the drone. Okay, since I hope everybody is still aware, no sleeping. Okay, now this is the inspired drone from DJI. Okay, so the original camera from this drone is actually GoPro. Okay, and normally people use this Inspire for film, take a video, or for the construction monitoring, you know, because they just use the GoPro camera. But we use the multispectral sensor, so we change the bracket. Okay, so I will show you how we change the payload to the Inspire drone. Okay, so of course we need to connect the iPad or phone to the controller. Okay, remote control using the USB wire. Okay, and then I try to make it a little bit fast. And then we need to put the camera. Okay, you see, this is the GoPro camera. GoPro, okay? We put in the bracket, and then before we fly, okay, we need to calibrate the compass. Okay, so this is the step how we calibrate the compass. So I will show you. First, we need to put the camera first. Okay, the GoPro camera. Okay, and then we need to follow the instruction how to calibrate the compass. Okay, because after this we want to change the GoPro to the multispectral, so we have to calibrate first. So we need to go to the DJI Go apps. Okay, it is straightforward with the Anthem. Okay, just you need to follow the instruction. Okay, to calibrate you need to do the 130 for the horizontal, 180 degrees. Okay, and also for the vertical same. So when our phone, okay, our phone we give the indicator whether the calibration is correct or not, or is ready or not to fly. Okay, so this is how we actually setting, okay, the calibrate the camera. And then after we calibrate the compass, we need to change the sensor. Okay, remember this actually original with the GoPro, okay, RGB. Okay, but now we want to change to the multispectral. We put the multispectral camera where the multispectral have 4 bands. You see? Okay, now you can see the difference of the sensors. See? The sensor is actually we custom made the bracket. Okay, and then we put the multispectral in here. This is actually the Mikasan parrot sequoia. Okay, the brand is from parrot sequoia Mikasan, and we need to connect the wire to the drone. Okay, so that the image, the sensor we capture the image. Okay, so we need to calibrate again for the multispectral, because multispectral is collect the reflectance of the light. Okay, so we need to make sure first the GPS. Okay, and then we need to check the white reference. Okay, when you use the multispectral or hyperspectral, you need to calibrate using the white reflectance or white panel. Okay, here this is the example how we do the calibration for the white panel. Okay, so when we bought this sensor, the factory will provide us, okay, the white panel, and we need to follow the instruction, and then we plan the waypoint. I think everybody clear with this. Okay, and then when everything is set up, so we can fly the drone. So the drone will fly based on our waypoint. Okay, this is the example in paddy field, and I work a lot in paddy field before this. Okay, So this is just a break for you so that you can see how the drone works in monitoring. Okay, this is just only for setup, not goes to the processing yet. Okay, so you have to transfer the image, do some processing to get a useful data. Okay, and then for this research, just to monitor the crop growth using GIS and remote sensing at early stage. Okay, so the methodology here, we use the near infrared algorithm. Okay, I will show you. So this is the area for the study area in Kelantan. Okay, and we take at very early stage, 12 days after planting and 23rd days after planting. We use the multispectral sensor, and as I mentioned, we need to do the calibration. We need to put the GCPs for the georeferencing analysis after this, and then we run the NDVI map. Okay. And what is NDVI? Maybe some of you already aware what is NDVI, and especially NDVI is actually very famous in agriculture because it's actually measure the density of vegetation. Okay, meaning that is the value of the NDVI is 0 to 1. Okay, is the value is near to 1, meaning that the density of the vegetation is really high. If the value is below than or near to 1, meaning that the vegetation density is really low. So based on the value or scale, we can classify the healthy or unhealthy plants. Okay, so this is the algorithm for the near infrared minus red and divided by near infrared plus red. So that's the reason why in NDVI we need to use the multispectral. Without near infrared, we cannot run this algorithm. Okay, so this is what I mentioned, how the healthy leaf will reflect more on near infrared. Okay, for the stress leaf, they will reflect same level with the green. Okay, but if the dead leaf, they will reflect a same level with the blue and blue and red. So if you still remember how the photosynthesis happen when the chlorophyll is actually observe the blue and red light. Okay, that's why if you see a plant factory where they use the LED light, then we use the blue light and the red light because that what the plants need. Okay, and also this is how the reflectance of the image, you can see the healthy leaf will reflects more compared to the stress leaf. I think I already mentioned this, and this is the visible band where we only can see from RGB, but the near infrared we cannot see. So this is how we can use the hyperspectral to measure the crop condition of our plants or plantation. So for the classification, okay, you can get from a lot of reference from the journal paper or for any others article, but I really encourage you to check, okay, because this classification sometimes is suitable for certain crop. Okay, so if you want to do for oil palm, okay, you need to check what is the healthy indicate for the oil palm, maybe from 0.8 and above. Okay, for the rubber. So this is just for your initial reference, but then you need to cross check back because some plant have different reflectance. Okay, so this is just for your reference, general reference, but then you need to cross check with the literature review and your data set. Okay, and for the results, okay, we want to identify at the early stage. Okay, so we can identify the uneven area, water volume, okay, water flow, and also profiling. So you can see this is actually very early stage. I think at 20 days after planting, you can see there's a lot of soil, but actually inside here there is a paddy field. But because of so small, you can see in the image only like a soil. Okay, but actually there is a lot of paddy field. Okay, but you can see the drought area where the area is didn't get enough water. Okay, and the uneven area. Okay, inconsistent water. So this is what we can monitor at the early stage. If this situation happen, you can treat your plot. Maybe you can put more irrigation for this area. Okay, or you can check back, or you can treat back to that specific area. Okay, and we also can calculate using the GIS software to calculate the area of the uneven area. Okay, for example, when the surface is not flat enough, okay, you can see some of the area flooded, some of the area is didn't have enough water. Okay, because if you are familiar with especially in Malaysia, the level of water level for Malaysia is 5 centimeters. Okay, so when we put the water up to 5 centimeters, if the area is uneven or maybe is higher compared to the others area, maybe the area is dry. Okay, didn't get enough water. Or if the area is lower, like this, it will be flooded. Okay, so it will give the impact to the crop growth later on, and maybe you can get some losses to that specific area. Okay, same goes to the slope. Okay, you can see where is the water volume, okay, for the specific area, and water flow. So where is the area we get first we get faster water, and where is the area didn't get enough water, sufficient water. So you from this you can see maybe because the in Malaysia we call pintu air, the water goes and go in and go out. Okay, it's very near to the area maybe, so it didn't have enough water or flood the area. So you need to check back, okay, with the water flow and so on. And this is the profile is really important. From this we can see whether the area is flat enough or not. Okay, even from the map we can see clearly the effect of the tractor tires. Okay, when they make the cornering, we can see the effect of the tire in the plot. So supposedly farmers need to treat the area first, make it flat by using manually lah. Okay, but then where they didn't do the treatment, they just simply broadcasting the seed, and finally you can see some of the area have a problem. So this is how we can actually do the early detection or early warning monitoring. Okay, and this is how the map looks like when I think this is at the productive stage. Okay, you can see this is the RGB map. So when we plant the seed at the same day, same time, okay, so we are expecting the growth is also consistent, same, right? But from the map you can see the area have a variation of the color. Some of the area have green, some of the area have red. Okay, so why is happened? This is because first we also apply a different fertilizer for different plot. Okay, secondly because of the effect of the water irrigation that I mentioned before. Okay, maybe some of the area have flooded, maybe some of the area didn't have enough water. So you can see the green is a good area, okay, healthy or have a good reflectance, okay, of the near infrared. But the red maybe have some issues. Okay, maybe drought, or maybe it's not suitable for the fertilizer, because we also put some different fertilizer, okay, because we want to test which fertilizer is the best. Okay, and also maybe the different management. So there's a lot of factors. So but when we fly the drone, we can see what is actually happen, and we can advise the farmers what should they do for the next season so that they can get a higher yield. Okay, so we identify the uneven ground surface, poor irrigations. Okay, and also we can help farmers by using the UAV. They can actually see for the overview of the area without need to go or walk to the whole plot. And we also recommend to follow up their crop growth. Okay, and remember, in the smart agriculture is we already touched the drone. Okay, and remote sensing, and also smartphone. Okay, so this is a project from my student. uh, Remember that all the data that we collect in paddy field, we put all the information in the mobile apps we call as Paddy to You. Okay, so my students, Noatira Roslin, she was a master student and already graduated last year. So she developed the mobile apps, okay, for the farmers by gather all the information that we collect using the drone data. Okay, most of the apps, mobile apps, didn't have any drone data, didn't have any NDVI map. Okay, but in our mobile apps, we put the drone data and NDVI map so that farmers can see or cross-check back their previous season, how it looks like. Okay. And the mobile apps known as Paddy to You. Okay. So we put some menus, okay, in that mobile apps. For example, the information of the variety, the map, okay, and then the crop growth, rice check, water flow, okay, and pest and disease information, weed, okay, and then the forecast and some list shop, okay, to buy the suppliers, and also some picture. So farmers also can take a picture and upload to the mobile apps. Okay. And we also test to the farmers. We give our farmers to use the apps and we get some feedback. Okay. Any suggestion from them because they need to use it. So we, based on that suggestion, we improve the mobile apps. Okay. So I also want to show you my small project for this sprayer drone. I think in Indonesia also maybe you also use the sprayer drone a lot. Okay, but I'm not really expert in sprayer drone, but I am one of the team. Okay, the principal here, I think Dr. Suhaizi. So I just want to give you a brief. Okay, how the comparison between the traditional method with the drone sprayer. Okay, you see, yeah? Okay, for the traditional method, farmers will go to the field using a blower, okay, and then we spray the pesticide or herbicide, right? And then need go inside the plot, okay, then we walk plot to another plot, right? What happened here, if you see clearly, first they already damage the plant itself because they walk inside, right? Secondly, they also transfer the pest and disease to another plot. Okay, so at the same time, they actually spread the pest and disease. Okay, but when we use the spray drone, okay, you can see the drone will spray to the area without any direct contact, and they can fly to the whole area without touch to the plants, without damage to the plants. Okay, so this is what we also still in research, okay, to do the spraying, especially for the weed management, because farmers apply the whole area, but when we produce the weed map, we can actually put the weed map in the sprayer drone so that the drone will spray to the specific area. That's how we call as site specific weed management, and it can reduce the cost and input. Okay. And then another project, this is a pineapple in UPM using the drone, also for weed. So you can see this is a very small project I do with my undergraduate student. So the difference between the good management and bad management, just we apply the herbicide, and when we didn't apply the herbicide, and then when we fly, you can see some of the area didn't have not much weed, but the area have a lot of weeds, and it also will give the competition to the crop itself. So this is just for the visualization, and also maybe we can measure or calculate how much the wheat area, okay, how the crop condition of the pineapple and so on, and it's still a new okay for us, and I didn't have final result yet. Okay, and finally this is the durian. I think Indonesia also have durian plantation, and we actually collaborate with the company Marvelin Sdn Bhd. We use their plot, okay, and then we fly the drone, and this plantation is very new. I think it's about 2 years old age. Okay, the age of the durian is very young, and we fly just to do the GIS for database. Okay, so that, and this area is actually using a fertigation system. They use the fertigation system, and then we plot using the GIS, and we integrate with the ground data. Okay, so based on the GIS, we can know any others information, and we can do some spatial analysis. Okay, I think I just showed just for the database here, and this is final. Okay, the fertigation system using mobile app. So this is also another project by my master student. Okay, where we actually use the IoT system. Okay, and then we use the sensor, okay, to trigger the irrigation system. Okay, so I will show you how we do the setup for the fertigation system. Okay, we do the experiment to compare between the IoT and without the IoT. So we want to check which one it gives you a more efficient or good growth. Okay, so we use this sensor. There is a 3 probe here that measure the EC, pH, and also the moisture. Okay, and then it will link to the water tank. Okay, water tank here, that if the value is dry, it will trigger the water to the fertigation system lah in this plot. Okay, so this we actually use the tomato cherry in glass house, and my students is actually develop the mobile apps to monitor, okay, especially for the water quality, water level, water pump, air quality, and soil quality. So every minute the data from the sensor we store in a cloud, and then we can visualize the data using the mobile apps. Okay, so we can see the current value for EC, pH, temperature, and so on. And if the water tank is low, they will give the notification for us so that we can do the top up the fertilizers. And of course, for the fertigation, we use the AB fertilizer. Okay. This is one of my IoT project. Okay. For the conclusions, okay, for the smart farming, okay, you can see there's a very significant potential, okay, to help farmers and for the farm or plantations, and the integration between the IoT and UAV will help to collect the data and check the condition of the crop, for example, like nutrient levels, soil condition, irrigation, weed infestation. Okay, especially we are discuss a lot as well about weed management, and also precision agriculture will allow farmers to monitor their farm systematically and efficient way, because we try to minimize the input but maximize the output. Okay, maximize the profit, the yield. Okay, and smart farming will allow for food traceability and lead to increase the food safety and food security. All right. So this is a reference and some photo. I think I already showed some of the photo, and this is the glass house that we plant the tomato cherry and do the fertigation system. This is some area in field, in paddy field. So thank you so much, Arafat. So if you have any suggestion or comment, we learn together. Okay. I also still new, still learn, and I'm happy to share my experience to you. So thank you so much.
Okay, really nice and insightful presentation, Miss Dr. Nurasma. And I think student and participant here surely got a lot of insight into smart farming, precision agriculture, and remote sensing. Student and participant, now is the time for discussion, but before it, we have first question from Miss Rini Suryani, doctoral student in Andalas University, asks about to Miss Dr. Nurasma about WA number. My Miss Rini will make intensive relation with you, gitu. And I also will ask to Miss Dr. Nurasma. I think hyperspectral is a high level of remote sensing, but the function is important for precision agriculture. And drone is the basic key for remote sensing, but we must have permission to use it. In here, there is the Dean, Kadep, Kaprodi, senior lecturer, secretary program, and my agro will buy and study more about using drone. But the question, how much money to buy a drone like Miss Dr. Nurasma? And second question, I have research using remote sensing to knowing water soil availability under coffee plantation before by using NDVI, NDSI, land surface temperature, but how to mapping by hyperspectral, because I have never before, or we just use OBIA or VLS or how. And the question also from Mr. Fajrin Pramana Putra, the lecture from Undip asks to you about there are factors that affect from crop yield that may be forgotten, namely with so far with are controlled when with appears or grow on agriculture land by mechanical, chemical, or biological. Mean by looking at the critical point of plant against with. According to Mr. Nurasma, is it possible to forecast with seed bank in the soil by remote sensing, so that they can prepare for control or be controlled while they have not germinated? Or in a little question, how to know with seed bank in the soil by remote sensing? The little short question is that. And to other participant, please, if you have any question or even comment, just raise your hand virtually being the Zoom. Maybe the question Yes, the time for Miss Dr. Nurasma. Okay.
Okay, thank you, Arafat. Okay, very long questions, so I tried to answer one by one. Hopefully, I
Yeah,
didn't
yeah.
miss any questions.
Sorry.
Okay, thank you so much for your attention and your interest in this topic. I know it's like a very interesting topic, right? And you try to do a lot of things with this. And okay, first of all, when I started to use the drone in my research, I started during my PhD. Okay, and during my PhD, we have a collaboration with other university that actually have the drone. So we just use their expertise to fly the drone and get the data, but the image processing we have to process ourselves. When I go to UPM, I come back to my country, we didn't have any drone, so we have to buy. And so we started slowly. Okay, when I arrived to UPM, I meet one professor, Parazi. He actually from the Institute of Itafos. He has some grant. Okay, that he has some money. If he said if I want to use it for my research, I can use it. So I introduced a drone. Okay, so we bought our first drone is actually for the Rgb Phantom. I don't know in Indonesia price, but in Malaysia, for the Phantom RGB, I think last time we bought around I think if I'm not mistaken, about 11,000 ringgit Malaysia. But now I'm sure it's quite cheaper now, because last time I think it's 2017, 2018. It's still expensive, but now technology very fast, and when they have a new model, they decrease the value, right? Now we have a hyperspectral and so on. And actually, to be honest, when you want to start with the precision agriculture method, for the start, it use a lot of cost. Okay, we need to invest for the technology. Okay, because it's really expensive for the started or to begin the project. But you can start small. Just maybe you can buy a small drone with the RGB sensor first, and then when you're familiar with that, you can upgrade. Okay, if you have a programming background or mechanical background, you can custom make your own. But I really suggest you to just buy a um at the market. Is easy to use. Okay, rather than you have to think how to operate, how to set up. Okay, and for us, from the RGB, multispectral, thermal, and now hyperspectral, it costs us a lot. It's very expensive together with the software. When you use the drone, okay, most of student or users, when they use drone, they forget about the processing. Okay, especially when you use the drone data, you need to have a powerful computer to process the image, to do the image analysis. Okay, and you need a very powerful computer to do the processing, and it really expensive. Okay, so how to answer how much the cost is really expensive for sure, but I think for the first started is expensive, but then you can maintain, you can use for several years, so it will goes down the value, meaning that if you already have your own drone, you can maybe do a service provider. You can charge if someone want to take the data with you, so that you can generate your own income for your department or your faculty, right? So that's what we did actually. That's what we did. We also do some services if others department want to use our drone. We put some charges minima, so that we can use that money for the maintenance, for the repair and so on. Okay, but I think it was to invest. It was to invest. But I cannot calculate everything here. I think maybe it's really expensive, especially for hyperspectral. We just bought this year. Is cost us about, for the sensor only, about 300,000 ringgit Malaysia. Bukan 300, sorry, 300,000, yes, 300,000 ringgit Malaysia. Is like same price for a car here in Malaysia. Like you can get 300,000 for maybe Alfred, no Alfred, maybe Honda, you know. You can get a car with that same price, you know. Continental car, so it's really expensive, but then you can do a lot of research with that, and even we already have that sensor hyperspectral, we still study, we still do a lot of testing, still do a lot of study with that data. So we didn't have any finding yet, but it's really quite interesting to study that kind of data. Okay, that's the cost. And then I think number two is about, I not really remember about the NDVI and NDSI. And then they use the OVIA and PLS. And then what is the questions? Can you repeat again, Arafat? For the second question.
The question, how to mapping by hyperspectral.
Mapping. Okay. All right. So, I have some experience by using the RGB multispectral and hyperspectral. So when we use the multispectral, it's same concept like RGB. We can mosaic using Agisoft. It's straightforward. And then we can do many others classification method, supervised, or you can use machine learning, okay, or BIA, PLS. But for the hyperspectral, it's really tricky. Okay, you cannot simply analyze. You even to mosaic, you need to use. It depends on the brand. Okay, so in our case, we use the Resonon PKL. It's from US. So you have to mosaic using the Spectronon, their software, and this sensor is actually collect the data using the push broom technique, like satellite imagery. So if we scan like push broom, like satellite, it's not like multispectral, capture, and then overlap, right? This is a push broom. Is we scan one stripe. So how you want to mosaic? We cannot use the Agisoft, or we cannot use the PS4D, we cannot use, but we need to use the specific software called as Spectronon. And we're still doing that until now, because the company provider still do a training to us how to use that, and we still learn. And it's really tedious to mosaic it one by one. Okay, and how to do the analysis? After we mosaic, after we do some corrections, we can actually add to the MV or GIS software, any image processing, and you can run any other algorithm. Okay, it's like same like multispectral. You can, whether you want to run the machine learning like support vector machine, or you want to run the random forest, you can run. It's possible. But in our studies, since we didn't have the clean data yet, we cannot analyze the data yet. That's why today I didn't show you the result, because we didn't get the result yet. It's still quite new for us as well. We just started like this last month. Okay, so we still do the processing. Okay, I think I'm sure it's really complicated at the beginning, but maybe after this, when we have some experience, we can get more understanding. Okay, but what you can do is you can also read from the literature how people do the analysis. And for us, using the PKL is quite challenging. Okay, and hopefully we can publish Q1 paper, because it's really hard to do this. And even for the literature review, we found several papers that we can refer as well lah. Okay, and then the next questions, I think can we see again the questions?
How to know which seed bank how to
seed
know which seed
bank.
bank. Yes,
Okay.
very much
All right.
sensing.
Okay, so I understand in weed management, basically we control by using mechanical method, biological method, right? So how we use the remote sensing, okay? Actually, when we use the remote sensing, especially the drone, okay? Drone can fly, you can set what the altitude you want to fly, okay? And what the spatial resolution you want. But we can only scan on the surface of the earth, surface of the soil only. If there is a trees, you only can scan the canopy of the tree, canopy of the plants, okay? So the question is, if the seed bank in the soil, okay, do we can detect? So I I'm not really sure because I didn't do this experiment yet. But what I know, what we can detect only at the surface, on the top of the soil. Okay, but when if you want to know the nutrients, okay, we can actually identify based on the spectral signature of the soil or the color. Okay, but for the seed bank, okay, I think it is quite difficult. I don't know. I don't know. Okay, but I think normally what we scan only on the top of the surface only, unless you do some interpolation or prediction where you actually do the data set, collect all the data set, and then you do cross check to the ground, and then you do the interpolation like kriging or IDW to check whether the area have seed bank or not. Okay, so you have to cross check, but I never done that before, so I'm so sorry. But what I know, remote sensing or drone data only can scan on the top of the surface or canopy. Even though if you want to detect pest and disease, you just scan the leaf surface, surface, and the leaf color is, we can check the symptom. Like if yellowish, maybe there is attack by the other disease or other pests. Just like that. Okay, we cannot go through to the inside that soil or any surface. Okay, so far what I know lah. I'm so sorry. Yeah, I'm not answers very well. Okay, thank you for the questions.
Okay. And the last question, maybe because the time is 11. But the question is very much. Maybe Mr. Irfan will ask to Miss Dr. Nurasma immediately. Oh yes. Oh, this the question very much. Okay.
Okay, maybe I can read.
Okay. Before I miss yeah, pardon me, miss, if I was having technical difficulties. Okay, miss. Pardon me. First of all, it was quite a splendid presentation, and it's given me plenty of about precision farming with technologies. So from there on, yeah, actually not couple, but several questions that I might want to ask. So first, is there any application of drone in monitoring land fertility status, as the colors of the land itself might indicate the land fertility itself? Is there, if it exists, is there any sensors that calculate such tasks? And the second question is there any particular application of drone-based sensor in monitoring pest or pathogen in crop in general that might be able, and also that might be able to distinguish each individual, the pathogen or the pest itself? If it does exist, what kind of sensor that usually used in order to run such tasks? And then the third question is, are there any specific modification that apply towards the drone that you usually used in order to, yeah, again, in order to run each specific task? For example, in order to, what is it? For example, using the GoPro, or might be the what is it, the sensor of the color of the land itself, and yeah, is there any particular modifications? And then the last but not least is in terms of side effects on applying pesticides with drones. Are there any side effects that might occur towards the natural predators that lives in the land itself?
Okay, all right. Thank you, Irfan. Okay, very long question. So I try to recap. The first one, how we can identify the land fertility status, right, using the drone. Is it possible or not? All right. So if we want to check the land fertility, okay, as I mentioned before, we can only scan or capture the data on the surface, the top of the soil. Okay, so how we want to know the fertility of that soil? Okay, so first we need to also do the soil sampling. Okay, when you use drone, it's always come up with the GIS. Okay, GIS software, so GPS. So when you do the you take the image, you also need to do the soil sampling, so that you know the condition of the soil. Is it fertility or not, fertilize or not, right? So you have to check in the ground whether you do soil identification, or you send the soil sample to the lab. Okay, normally when you send sample to the lab, you know the micronutrient, the nutrient, NPK, and so on in the soil, right? So how to check the fertility land status using the drone? You cannot simply use the drone only. You need to cross check with the ground data. Okay, when you check with the ground data, maybe I think you can plot the soil sampling in the GIS, okay, in the map. So you can do some interpretation, or you can do some interpolation. Okay, from that we come up with one zoning. Okay, soil fertility zoning, where is the zone is higher fertility or lower. Okay, so you cannot just scan with the drone only. Okay, because as I mentioned, the drone only capture the surface of the object. Okay, but for the image, you also can do some of the analysis, like using vegetation algorithm. Okay, in vegetation algorithm, there is a lot of algorithm that you can test. So what you have to do, you need to check from the literature how people do the check the land fertility using the image processing, for example. There for sure they will have some image processing analysis with the cross check at the ground. So wherever it is, you need to do the soil sampling. That's number one. Okay, number two, is it possible to distinguish between the pests and pathogen in your crop? Okay, as I mentioned, when the drone fly, they only capture the surface of the leaf. Okay, but from the leaf or from the canopy, you can actually check the differences color. Okay, that's why you need to have your reference map first, your reference plants, how the color should looks like. So if difference with the healthy color is actually indicate that the area have a problem with the pest and disease and so on. So you have to cross check again. You have to cross check. But in leaf, normally there a lot of vegetation index you can try, and some people actually I think a lot of research on pest and disease using UAV, using drones, so you can find it. Just in my research is I'm more on focusing on weed and crop growth. I didn't touch on pest and disease yet. Okay, but I think that I'm sure there is a method. Okay, how to identify the pest and disease or pest and pathogen using the drone. So what how to identify what kind of drone that you asked me, what kind of sensor, whether hyperspectral, whether multispectral. Okay, I will suggest you should use the multispectral. It's easy, it's straightforward, and you can get near infrared that you can do a lot of vegetations algorithm after that. You also can do hyperspectral, but again, hyperspectral is really difficult. Honestly, when I already use it by myself, it's really difficult. Maybe it's still new, right? It's still new. It is quite not really user friendly. You have to study a lot in hyperspectral. So if you want to try for pest and pathogen, I think multispectral is enough. Is okay, is sufficient, but you have to do image processing with any other algorithm. For example, like maybe you can run the vegetation index. You need to check from the literature, okay? And whether the drone will affect the natural predators or not. Okay, this one also, as I mentioned, in sprayer drone, we are still new, and I'm not really do this experiment. But I think because we also, what we did now in UPM, we try to put the weed map in the sprayer drone, so that the sprayer drone we spray only at the patches, weed patches, the specific area. So whether is we harm the natural predators or not, that's we need to do another experiment. We didn't do any test yet. So but what we do test, we actually put the sensitivity paper to the leaf, so that to make sure whether the sprayer drone is actually reached to the leaf or not. Because if you compare the manual blower with the workers, the input, the herbicide or pesticide is reached to the leaf very well. Okay, you can see the leaves is wet. Okay, meaning that the leaf get the herbicide or pesticide or fertilizer. But when we use the spray drone, what we do the experiment, we don't know, is it enough? Is it sufficient, the input? So we put the sensitivity paper to the leaf, and we check the density of the input, whether it's rich or not, and the amount of the input for the herbicide, for example, is different. Okay, it's different with the manual sprayer, because manual sprayer you have to follow the guidelines from the bottle. Okay, but for the spray drone, we have a different content. We put a little bit higher. Okay, because the mist that goes to the plants difference. Okay, but it's sufficient enough. And what we did here is we more on spot spraying. Okay, but we didn't touch the natural predators yet. But that's a very good idea, information for us, so that we can consider that in our experiment in the future. Right, thank you, Ifran. Right, any
Thank you
other
very much,
question?
Dr.
Okay.
Rosma.
Oh, okay, Miss. I'm so sorry because we have extra question.
Okay.
But the question I think important, Miss Dr. Nurasma. The question from Muammar. Okay. Can we do precision farming on a small scale using smart farming, and what technologies can be applied without requiring special skill, or can we learn independently? And the second question, or the last question from Julian, may you ask by yourself, Julian? Okay.
Okay, thank you, Muhammad Zafar and Julian Christiara. Okay, actually, for the precision farming, okay, from the technology itself is actually come from the Europe, from US. Okay, it started from Europe, US, and then it goes to Asian like Japan. Okay, goes to the Indonesia. and goes to our country, Malaysia. So normally, what they did, they actually implement a very huge area because their farm is very big, right? If you go to the Europe or Netherlands or US, their farm is very big and it's really efficient to use the precision farming. They can cut a lot of costs because everything need to be precise. Any space need to be planned, need to give yield, right? So how in a small scale, especially in Malaysia, we are very small country compared to Indonesia, is very big. Okay, actually, um, it's not actually in my opinion lah. Okay, this is my opinion. It's not uh it's not really about the size, okay, but it's actually about the precise. Even though you have a small scale, you still need to be precise, right? Why, if you have small scale, why you want to waste everything, right? So I think is the size is just a number, but what you have to do is the precise. Everything you do, everything you apply need to be precise so that you can cut the cost. At the same time, you can um, save the effect or the effect from the environment, from the chemical usage, for example. So what is the technology that can be used? Okay, for the small scale, if you want to do precision farming, I will suggest to use the drone because drone is really suitable for the small scale. If you have the bigger scale, I will suggest you to use the satellite because satellite we cover the whole area, the very big area. Okay, what the technology is suitable, you need to check. Okay, first, even though a small scale, you can apply the precision farming. Secondly, even though you have the small scale, you can use the small drone, okay, with the small maybe you can start with the RGB first, RGB sensor, okay, RGB camera, okay, and then do we need any skill? Yes, of course. It's actually practice make perfect, right? So you have to practice everything, you have to practice. It's not one day learn, okay. You have, even me, my degree is actually GIS. It took me 4 years to finish my degree, and then I continue my master's in web GIS and my PhD in precision farming. So it takes years, okay, to understand and to get familiar with this kind of technology. And again, even though you talk about precision farming, in the future will be a new technology coming. Right now we have IoT, you know, we have the smart farming, big data, and everything, AI. So we need a special skill, but you can learn and you can practice. Okay, so if you use the RGB drone, maybe it's quite simple to use. It's straightforward to use and easy. Okay, that's why I encourage you to use like from the market drone, because when you use the available drone, they already simplify everything. So they already teach you very easy to use. Because I started with the custom made drone. I started with that. So I can see the difference and very difficulties when we actually custom made by ourselves. Unless you are very chemical or technical person. Okay, but me, I'm really like something very simple, straightforward. So you can use the DJI Phantom. It's really straightforward. Maybe it takes some time to learn. Okay, to know how to fly. That's why I show you a video just now. You need to follow all the steps. If you miss that step, like calibration, do the white panel calibration, you will never get a good data, because the data is really important to do the analysis and to come up with the any other output. Okay, so you need to learn, you need to practice, and you also can learn independently, but you need to practice. Because I found one farmers, okay, in Malaysia, he bought himself a drone. Just you can buy the drone from Lazada, okay, and then post to his house, and he just learned using YouTube to fly the drone. Yes, you can learn, but I think you also need basic fundamental. Okay, especially when we say drone can do precision farming, how they scan the area, how to do the analysis. So the most important is actually the image processing itself, because we actually capture the image, the gambar tu area imagery, we need to process. So that's the skill that we need to do. Whether we want to use the remote sensing software, whether we want to use the GIS software, or whether we want to use the image processing like MATLAB or programming. Okay. And then it takes time or not? Oh, of course. For the first time, it really takes time. Okay. Even me, to learn how to mosaic, to use the IT soft, it takes some time. But if you have a lot of experience, it will more faster after that. Okay. And if you want, is in Malaysia, first, if you want to fly drone, you need to have a license. If in Malaysia, okay, I don't know in Indonesia, but I share in Malaysia perspective. First, we have a license, and then we need to apply a permit. So before you fly the drone at the area, you need to get a permission first, even though that area is your land, the permission from your government. Okay, and then it's good if you have a certificate or certified license or a permit, because everything you already know all the guidelines. Okay, and when you need to do the processing, again, as I mentioned before, when you buy a drone, you need to buy together with the machine, the computer, the processing machine. You need to make sure your computer is really powerful. Maybe you can buy a workstation, a very high-end processing, because wherever you want to deal with the drone data, it's really heavy and need very high performance computer. So it takes time. So if your computer is very slow, it really takes some time to do that. If your computer is very fast, and it takes faster, right? So again, it depends on your experience and your if you fly, if you do a lot, you will get really familiar and very easy to do. But for the first time, it takes some time to understand everything, learn from the mistake, learn from the error, learn from the noise, so it will take some time for you. But it's possible to get very good data after you already have enough skill, good understanding how to run that tools. Drone is just a tool. Okay, I always say to my students, drone just a tools. Okay, it's a very dangerous tools. You cannot simply use it anywhere. You need to know how to operate that, so that it's not dangerous to the public people and to yourself. So you have to careful to use this. Okay, that's why in Malaysia we have a license, so that you can make sure if you fly the drone is safe enough to everyone. Okay, in my case, our pilot have a license, okay, to fly that. Okay, all right. Hopefully I answered you, Julian. Right, thank you for the questions. Wow, many questions.
Yes. Okay. Thank you very much, Miss Dr. Nurasma, for delivering an opening and interesting presentation. Okay, that was the conclusion. Is take by yourself, and I think we got a lot of enlightenment for today. So I'd like to thank so much to our speaker, Miss Dr. Nurasma, for the new insight and deeper knowledge about smart farming and precision agriculture, crop and weed management using remote sensing. We are looking forward to welcoming you in person in right here in Semarang, Indonesia. And also to all student and participant here. Thank you very much for joining us, and thank you for your active participant. Hopefully, the topic will be benefit for everybody. Amin. And finally, I ask today moderator apologies if there are any shortcoming in guiding this discussion. Thank you very much and see you on the next occasion. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Arafat. So thank you, everyone.
Okay. Beforehand, ladies and gentlemen, thanks to our moderator, Setral Arafat, SPMP, for leading this session. Okay. Beforehand, ladies and gentlemen, we would like to express our sincere gratitude for our today's speaker, Dr. Nik Narasma Jaya. As our token of gratitude, of appreciation, we be honorable to grant Dr. Nik Narasma Jaya our certificate of appreciation. That might be come in short.
Thank you.
Yeah. Okay. There's the certification. Once again, thank you very much, Dr. Nino Rasmace. Yeah. Ladies and gentlemen, now we come to our closing session. And last but not least, I would like to leave you with a simple yet powerful quote by Søren Kierkegaard, a Danish philosopher, who once said, "Hope is a passion for what is possible." Throughout all the things we have learned in this meeting, may hope sparks patience that led towards new ideas that shall overcome any challenges in our present and our future. We are wholly delighted for your presence in this very meeting. Till we meet again in the next meeting, have a blissful day. See you.
Bye. Thank you so much.
Thank you so much,
All
Dr.
right.
Narasma.
All the best, everyone.
Iya.
All right.
Makasih
Assalamualaikum.
banyak, Unik. Unik Norasma.
Okay.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
I can leave now? Okay.
Yeah, thank you very much.
Bye. Assalamualaikum. Thank you, everyone.
Waalaikumsalam warahmatullahi wabarakatuh.